Okay, then, so I think we are on time. So welcome everyone. Welcome to the session. My name is Swati Rajwal, and I am currently pursuing my master's in computer science from India. I am a DeepLearning.AI event ambassador, and this particular session is brought to you by Pi and AI from New Delhi region, which is in India. So today we are going to talk about text classification, where we are going to predict good or bad statements using natural language processing. So this is going to be a very preliminary and beginner-friendly session for you. So before we begin, I would just like to inform all of you that this session is being recorded. This is for the purpose of archiving and reviewing, and I will share the recording with all of the attendees after the session. Other than that, there is going to be a survey after the session, and those who fill the survey will be eligible for a promo code for DeepLearning.AI course era courses. So I will share the details later on. Now the agenda, so what are the things that we are going to cover today, beginning with the goal, what is the entire session about, what are we going to discuss, then bag of words, which is a technique wherein we, kind of vectorize a text in numeric form. I'm going to discuss it afterwards. Thereafter, we are going to talk about the data set that we are going to use for doing the classification. And then, of course, the demo time. This is where we will be, building the model and using the packages. And then the closing remarks, where I will talk about the, what you can do afterwards and how you can avail the offers by DeepLearning.AI. So before I go ahead, let me just check if there are any questions in the chat box. Okay. Okay, thank you, Shahi, for confirming it's visible. All right, I think we are good to go. All right, so as I said, the goal here is to understand, first of all, text classification is a very common application in natural language processing, right? You have text classification are useful for email identification, for example, whether a particular email is spam or not, right? Even in your Gmail or Outlook, in Gmail, basically, you get some emails are sent to the spam folder based on certain criteria, right? Sentiment analysis is another aspect where text classification is useful, and tagging customer queries. So what do I mean by customer queries? Basically, when there's an organization and there are multiple departments in an organization, as a customer, I will ask my queries or I will put my queries to the company, and they should be able to identify that which department is best suited for my query. And that is what is the classification problem for customer's query. That can be done with the help of NLP by classifying the text, by identifying this query will be resolved by which department. So in this particular session, our goal is to create a classifier using Spacy package. Now, Spacy package is a very nice wrapper around which will allow you to build the model, and it is based on bag of words. So we are going to cover the fundamentals, but then we are going to use Spacy package to do the fundamental implementations for us. So this is a very beginner friendly package actually, and it is easy to understand and implement also. You will see that in a couple of minutes. Next, finally, we will be using that classifier that we have trained on the data set to detect the good or bad messages or sentences as we speak. Now, bag of words, like it is also called BOW, BOW. It basically turns any arbitrary text into fixed length vectors by counting the number of times each word appears. Now, this may sound confusing, but we'll look into example as well. But at its core, basically bag of word converts a given sentence or a given text into a numeric vector. Because for those of you who are already aware of machine learning or some aspect of machine learning, you must know that you must be aware that any model or any machine learning model requires numeric value, right? So for example, if there is some attribute in your data set, which is like gender, which can be male, female. So instead of having male, female, it's better to have zeros and ones instead, right? So that is the basic concept that any machine learning model or any NLP technique, for instance, cannot understand textual data. It requires some numeric values, and that's where bag of words can be useful for us. It is also called sometimes vectorization because we are essentially converting a given sentence into a vector. And the vector contains a number of the times a particular word is appearing in a sentence. Now, this may seem like an appealing technique, but at the same time, it has some drawback. The drawback being you lose contextual information such as where in the document the word appeared when we use bag of words approach. You will see the disadvantage as well. And it tells what words occur in the document, not where they have occurred. And once you have your document in a bag of word representation, as I talked about earlier, you can use those vectors as input to any machine learning model. So let's consider an example. These are the 4 sentences that I have presented here. And of course, in real life problems, the data will be more complicated and more complex than this. But as an example, let's consider that our data is only these 4 sentences, which are also called the documents, right? Now for each of these documents, we are going to find the vocabulary. So for all these 4 sentences, we are finding the vocabulary. So for example, vocabulary consists of all the words which are uniquely occurring. For example, the dog ran. So the dog ran. These are 3 words which can be added to the vocabulary. Now in the next sentence, you have the dog ran towards John. But in this case, the dog ran has already been added to the vocabulary list. So we are going to add towards John instead. So we have added towards John. And then the next sentence is a dog ran towards John and the pot fell. So here, so far, we have already added the dog ran towards John, and we are going to add the rest of the words. We have added and now D is occurring again, but we are not going to add it because we have already added it in our vocabulary. So vocabulary will consist of only the unique words from the document. And again, we have another sentence, John ran towards a dog, but this time all these words are already present in the vocabulary. So you can see how we have converted the textual sentences and found the vocabularies, the unique words occurring in each of the document or each of the textual sentences. So once we have the vocabulary in place, and again, I should remind that in real life problems, this vocabulary will be more complex. It will be bigger than what you have seen right now. So once we have the vocabulary in place, now we can do the encoding. This is the process of encoding. You have each of your vocabulary words here, and these are the sentences or the documents as you speak. Now, whenever there is a word in the sentence that occurs in the vocabulary, you are going to say it has occurred one time. So for example, in the first sentence, the line says the dog ran. Since there is the word the occurs one time, so we are going to put 1. Dog is occurring only one time, so again 1, ran 1, and none of the rest of the vocab is occurring again. So that's why this is the encoding for our first sentence or the first document. Let's consider the next is also similar. Let's consider the third document because it's pretty different. Here we have the dog ran towards John and the pot fell. Here the word the is occurring twice, and therefore we have referred that this is occurring twice, and then the rest of the words are occurring only once from the vocabulary. So I think so far you will be able to understand what's the significance of this particular encoding scheme. You are able to convert so many sentences into a fixed length vectors for each document. So for example, here the length of each encoding is 8 because we have converted each document as a series or as a vector of frequencies or as a count, right? So for example, the dog ran is now converted into a numeric vector of this. Similarly, the second document, third and fourth, all the documents, the textual documents actually, they are now converted into mathematical or numeric vectors. And as we know that any machine learning model will be happily able to process a numeric data like this. So that was about encoding. So yeah, this is bag of word approach. We had some textual data. We found the vocabulary out of it. And using the vocabulary, we were able to encode the document or the textual sentences mathematically. Now for this session, we are going to consider the dataset as shown in the on your screens. Of course, this is a very small dataset, but the aim of the session is to help you understand how to basically classify these sentences, right? This data is very small. If you want to work on more complex data sets, I would refer that you go to Kaggle. There are multiple freely available data sets that you can use over there. But here we just have this small data set, which is a combination of good and bad sentences. So each sentence is either good or it is either bad. So that's this data set. Of course, this data set may not appear even balanced to you. But here again, I'm iterating that a idea is to understand how to implement and not to look at the accuracies. Yeah, and as promised, it's demo time because this entire session is more hands-on rather than theoretical. I hope you were able to understand bag of words approach. It's pretty simple and straightforward. And again, there are certain downfalls to this approach and which are basically rectified by other approaches. But in this session, we are going to cover only bag of words. So let me quickly jump to my Google Colab for the demo. All right. Okay, so it says that I'm sharing my screen. I hope it's visible to everyone. So I'm using Google Colab for the demonstration purpose because it's easy to get started. There's no installation required, and I personally like to use, Google Colab on my web browser. So let's begin by loading the dataset first. And for as I said earlier, the dataset I have only handpicked the dataset myself. It's a very simple dataset, and I have loaded the dataset like this over here. Okay, you can just drag and drop the file and put it over here at this particular place. All right, so the first step is to begin with importing the pandas file, which is required for importing any CSV file, right? So let's just import the package. And next I'm going to load the data set. So for those of you who are aware of some machine learning aspects, this is how we read the CSV files, comma separated values. So PD is basically an object of the pandas. We are importing the library like this. And here you specify the path to your CSV file. The CSV file is located over here. So let's run it and confirm that it's visible. Yeah, it's working. It's accessible. If you want to see the data set, let me just quickly show you. It's very simple. Right. So these are the 7 sentences. Again, it's very small, but it will do the work. We will be able to quickly run it because the data size is very small. All right, so now we are going to work towards bag of words approach. As I talked about in my presentation earlier, bag of words approach is simple and even you can implement it on your own, right? You can implement the model. But Spacey is basically a Python language which will help us with the bag of word implementation. We do not have to create the vocabulary. We do not have to do the encoding. Everything will be taken care by Spacey. It will take care of the bag of word conversion and building a linear model with a class which is called text categorizer. We are going to do that right now. So since Spacey is there, like I have Spacey in my system, so I'm just going to import Spacey. And for the rest of the things, I will just explain here. So now what we are going to do, what we have done here is we have created a blank model, right? There are some complex models also you can create. For example, you can even create a CNN, convolutional neural network. For those of you who are aware of CNN, you can create CNN models also using Spacey, but that's out of the scope of this session. Here we have just created using this NLP equals to Spacey.blank. We have created a blank model, and this is now referred to as NLP throughout the demo. It will be referred to as NLP. Now, next thing, as I said earlier, that we are going to build a linear model with text categorizer class. Here we are going to use the text categorizer class. And what is this create pipe? Now, pipes are basically nothing but the classes. For example, in Java, you have classes, right? They do some processing. Any class can take a number of inputs or the arguments, and then they will return some values. In the similar way, we have pipes which are equivalent to classes for processing and transforming tokens. So if I have to explain tokens to you, for example, let's take this line, you are awesome. So here we have 3 tokens, you are Awesome. These are the 3 tokens, and that's what we mean by tokens. So yeah, moving on. So we have created an empty model, right? Now we have created a pipe using text categorizer class, and here we have mentioned the configuration. These are actually the standard configurations as we speak. These are not complex. These are standard. What do I mean by standard? Basically, these are the minimum that you require to create a linear model. So I mentioned it's a text categorizer. Then exclusive classes are set to be true. Why do we do that? Because this particular demo is based on multi-classification task, right? We have good and bad. So for that we have set it to true. And the architecture that we are going to utilize here is bag of words, right? So you see, we didn't implement anything. We just use this nice wrapper package, Spacey, and everything will be taken care of for us. And this entire this all right, my screen just froze. um, all right, okay, I can see that now. So yeah, once we are done with creating the empty model, and once we are done with creating a text categorizer pipe, we are going to add the text categorizer to the empty model like nlp.add pipe. So this is the entire way of creating the model and adding the text categorizer to the empty model. So let me just quickly run it and see if there are any errors or something. No. So here we are able to basically add the text categorizer to the empty model, which is here NLP. All right. Now the next step is to add the labels. So if you see our data set, let me just quickly go back. Our data set consists of 2 classes or the 2 labels. Either the sentence is good or the sentence is bad. These are the only 2 possibilities, nothing beyond that. So now we are going to let our model know what are the labels. So which can be done by using this. This is the object that we are referring for the text categorizer class. Textcat.add label good, and the other label is bad. These are the 2 labels that it can expect. So when you get 1, if you get 0, it means it was unsuccessful. And if you get 1, it means it is successful. Now the next step is to convert the labels, these good and bad labels, into the data that your text categorizer can understand. So let me just quickly do that. Okay, so before you go ahead, let me explain what this code is actually doing. Okay, let's understand it theoretically. So look at this first statement, you are awesome, right? In the data, it says this is a good sentence. This you are awesome has been categorized as a good statement. So what does it mean? It basically means that my label good is true and my label bad is false for this particular sentence. Now let's take another example. Let's say I hated the food. I hated the food. For this sentence, the label bad is true and the label good is false because this sentence has been tagged as a bad sentence. So since it is a bad sentence, we can say that the label bad is true here and the label good is false here. So I hope you are able to understand, how we are kind of creating this categorization even amongst the single sentence. For each sentence, we are going to find which label is true, and of course, the second label will be false simultaneously. So that's what we are doing here within my data set. All my sentences I'm saving to train text. This is what stores all of my lines, all of my sentences, the textual sentences. And the train labels will contain a dictionary, a particular dictionary, which will contain for each sentence whether the label value is true and the other label is false. If you're not able to understand, it's okay. I mean, I will just run the code and show you the result, which will explain everything for you. Okay, so with this we have basically divided the data set in 2 parts. Train text contains the sentences, the textual sentences, and train labels now contains a dictionary of labels. basically. And now we are going to combine both of them like this. So if you are aware of this zip function, I have this code. Okay, so if you here you see zip a comma b, this is how the results look like when you zip two list, two arrays, whatever. So just for your reference. Okay, let's run it. So now my train data here, which is referred here, train data contains both the text as well as the labels. So let's just see what the train data looks like, because this is a dictionary, right? So let's just see how does it look like. I'm just printing the top 5. All right, so for, as I said earlier, for each sentence, it is going to classify for each label, right? So we only have two labels. We have bad, like the sentence can either be bad or it can either be good. So instead of writing bad, bad, good, good, we are saying that for this sentence, bad is false and good is true, which basically essentially mean that this sentence is good. Let's take some another example. You look ugly. This is a sentence for which the value says bad is true and good is false. So what does it mean? It basically means this is a bad sentence because bad label is true. So yeah, so that's how we have basically, you know, converted the labels in the data to the form that the text categorizer requires, that text categorizer can understand. For each document, we have created a dictionary of Boolean values and for each of the classes, bad or good. All right, so that's done. Now the next step is, so let's just recall before we, you know, train the model. What we have done, we just loaded the data, right? Then we use Spacey to create the model, and we use text categorizer to build the linear model, right? And then we also told the model that, hey, these are the two labels that you can expect. And then we converted the labels in our data set into a form that text categorizer can understand. And this is the dictionary, that how it looks like. Now let us do the training of the model. How it is done. That is also taken care by Spacey. So Spacey has this function called mini batch. Spacey provides this function, but before that, let's see what happens in the first place. So before you can do anything, you have to first create an optimizer. So again, for those of you who are familiar with optimizers, they are just the function that modifies the attributes of the network, right? So your neural networks or any machine learning models, they learn iteratively, right? Every iteration they learn, and based on the previous learnings, they will update their weights. They will update their learning rates. So this may be beyond the scope of this session, but to just give you an understanding, an optimizer helps in reducing the overall loss, and optimizers help in improving the accuracies, right? Because every iteration, your model or your neural network is basically changing the weights and learning rates. So for this particular model, we are going to create the optimizer using begin underscore training function. So this Spacey basically provides this particular method which is used to create the optimizer to be used by Spacey for updating your model, right? And yeah, so this is how you create the optimizer. And after that, you know, it becomes very efficient to train the models in small batches. Of course, if those of you are aware of machine learning and, you know, mini batches, so it becomes efficient and even convenient at times to, you know, train the models in small batches. And Spacey as a package provides the mini batch function that will return a generator which yields mini batches for training. And how that generator is created, it is created using mini batch function, which is provided by Spacey. So you see, the fundamentals are constant. The fundamentals are still the bag of word fundamental, where, you know, it is creating vocabularies and encodings are being performed, but it is being simplified with the help of the particular library, which is called Spacey. All right, let's run and see if this is working. Okay, so this is working now. And in the next step, finally, we are going to split the mini batches. I'm going to show the output also, and that's why I have written the print statement here so that you can see what is happening in between. right? So now in this particular step, we are going to split the mini batches, individual mini batches into texts and labels. And then we are going to use NLP.update, where NLP, as I referred earlier, is our model throughout the demo. NLP is the name of our model. And we are going to update, and the optimizer is here. Here we have referred the, we have mentioned the optimizer, right? So let me show you how it is done. So the zip function is still the constant, the way we used earlier. Where is it? Zip. Okay, let me go back to the demo. Here is the zip function. How does it work? You have A and B. These are two, let's say, lists. And if you say zip A and B, this is how it will basically combine. It will combine both the lists in this way. All right, so here you see the batches are individual batches are the dictionaries. For example, for each sentence, you have the bad or the good attributes or the labels, and the same is happening for each of the sentences. So this is your original batch. But when you split the batches, here, if you see here, you have written zip, batch, text, and labels. So it is splitting them in original forms, in the two forms. So the splitted texts are "you are awesome," whatever the sentences are, and the splitted labels are cats, bad, good, and all those in the dictionaries, right? Now, once that is done, let's do some predictions here. All right. So here let's do some predictions. So now we are going to give some input lines to the model and see how it is going to predict it. So let's say if I say "you look ugly," right? This appears to be a bad sentence, but let's see how the model will predict it. So basically what happens, let me tell you before running the code, that here in this case, the scores, as you see here, they are used to predict a label. And what happens is the value of this method, predict function, it will be the probability of both the labels. So for example, let me show here. If you have bad and if you have good, these are the two classes that you have. And now this method will predict how good the sentence is or how bad the sentence is. And based on the probability, based on the highest probability, you will be able to understand whether the sentence is good or bad. So for example, if my particular this predict function returns something like 0.6 comma 0.4, right? So this is the probability value that it is returning. It means my sentence is 60% bad and 40% good. And out of, you know, zero point 0.6 and 0.4, what is largest? It's bad. Bad, the value of bad or the probability of bad is larger. And therefore, we can say that the sentence is bad. And that's how it is classifying. So let me just, run the, and this is what is mentioned by scores.argument max. I will show that in the next run. Here it will print the score. So here you can see these are the two scores, which is for, I think it is for good and it is for bad. I hope it is for bad because, you know, 0.5 is greater. So how do we find the maximum label? Using scores.arguments, and scores contains these two numbers. And once this predicted labels is found, we can find the label's name also, because if you remember earlier we had mentioned somewhere, yes. So here we had mentioned and added the labels to the text categorization, that this is good and there are bad. So label 1 is good, label 2 is bad. So I think this is going to produce the correct outputs. So here you can see, you know, this is producing bad, that this particular input line is bad. And okay, let's consider some other examples. Let me consider the example from my own data set only. And see, since the data set is very small, it's, the size of the data is small, it may not be able to, produce results for any line you say, for any sentence you input, right? For that, we need a large data set, large training data set. And you can even make it even more, what do you say, even more efficient if you divide the data set in, multiple parts, for example, training, test, validation data, and things like that. Let me just go back again and see how it works for some good lines. I don't like bad lines. I like food. So here you see the prediction scores is 0.5 and 0.49. So here, by the way, the predict method is the one which is, working on our lines. So you have given the line is being tokenized using the tokenizer method of your Spacy package. So again, see, everything is given to us. We didn't have to, tokenize our lines. We can actually manually tokenize our sentences as well, but, Spacy provides a nice wrapper for us to use the methods. So that so the sentence is being tokenized and it is then sent to the predict function for predictions. And this is our model. This is the text cat model that we have defined earlier, right? Let me run it again. 0.5 and 0.49. And I think class 1 was good and class 2 was bad. Therefore, this will be a good line. This is a good sentence, and that's how you basically calculate. You basically classify a sentence as good or bad. Again, not to mention the data set was pretty small, I agree, but this is how you can implement. And I can share some resources also with you. There are a couple of data sets on Kaggle also, which are freely available for you to, do your hands-on experience over there and apply the same method, the similar way, at the standard considerations, and you will be able to classify the sentences. So a couple of things I want to discuss here after this demo. Number one is the application. There are so many applications for this kind of classification. For example, if you own a restaurant, right, and you would like to understand what people good or bad reviews, right? There are movie reviews also which you can classify using this kind of classifier. And I am sure there are certain other couple of applications too, but just to give you a heads up, these are some of the applications. So yeah, so this was all about the demo. Now, if you have any questions, you can just put the questions on the chat box, and I will just take them up. And let me just go back to my presentation so that we can conclude and just have a quick Q&A session afterwards. Here is it. Okay, I'm just give me a couple of seconds. Okay, finally found it. So yeah, we discussed the fundamentals of bag of words and how encodings are done, the dataset and the demo. We have already seen the demo. I hope the demo was clear. And again, you must know that the demo that I presented here is very simple, just to get you started with the implementation. But you can just check out the Spacy website. It's documentation is huge, and you can go through some of their more complex models as well. And as I said earlier, they do provide CNN, convolutional neural network, as well. So you can literally you should check it out for once. And yeah, so that's all I had. I had also created a document, an article on Medium. It's published under towards data science. I will share the links definitely afterwards, after the session, with all of you, so that you can refer back. And yes, that reminds me, the most important part. After the session, there will be a survey which will be shared with all of you, all the attendees, that will offer a course promo code to the people who complete the post-session survey. And the code is for 50% off the first month subscription for any DeepLearning.AI courses on Coursera. And this will be highly beneficial for those of you who are just getting started with your machine learning or deep learning careers ahead. And this is the financial aid that we can provide to you. So that's all I had for this session. If you have any questions, you can ask them, and I would be more than happy to answer them.